Welcome to Operating System Unit 3, Part 1, Process Concept. So in this unit, we're going to talk about what a process is, define a process, what a PCB is, and process states. So a process. Well, a process you might think is a program in execution, but the truth is if you have only one processor and you have 20 active processes on your system, then only one is actually executing at a given time. So a process is actually an active program. So it's an active program and the execution would go in a sequential fashion. And there's all this information that is associated with a process, all of its resources, its program code, and the stack, and return parameters, and global variables, and the heap, and all this information that's associated with this process. And a program is just passive, and it's just a passive file that's stored on your system, and when you click on it or type in a command, it becomes active. When it becomes active, the operating system creates what's called a process control block, or a PCB, and that's just a data structure that the operating system will create, which for each process it will define a PCB. And one program can be several processes. For example, if you're running Excel on your system, then your operating system would have a PCB for that execution of Excel. And then if you open a new execution of Excel, which I do many times because I can't seem to figure out a way to separate each of my workbooks, so I have to make a new executing Excel for a different workbook, then that would make a different PCB, all coming from the same code and the same information, but with totally different resources. So this is some of the information that's in a process control block: the state of the process, the program counter, so that if the process gets interrupted, then it can go back to where it was and it doesn't have to restart from the beginning. The registers, any CPU scheduling out for information, which we will get to soon, where the memory has been allocated for the process, any accounting information that needs to be kept track about each active process, the devices, files, all that information will be contained in the PCB. And again, just to reiterate, the PCB is the data structure that is created by the by the operating system to describe each active process that's on your system. So no matter if you have 20 processes active on your system at a given time, and you have one CPU, only one will be actually executing and the rest will be active and in some other state. So these are the states that a process could possibly be in. But instead of reading these states to you, I will show you it in a directed diagram. So the process states are as follows. The new state is a state in which a program goes from being an inactive entity to an active entity. And the operating system creates the PCB and now has a unique identifier for this process and makes the decision on whether or not it will admit it into the system. And when we get to the next section of this unit, we will talk about the different schedulers and how decisions have to be made once resources have been used up, if a process can be admitted, or in the last unit we discussed this concept of swapping. Maybe your operating system will swap something out so that this new process can be admitted into the system. At any rate, it gets admitted into the system and it changes from the new state to the ready state. The ready state is the state in which the process is ready to get onto the CPU. Now again, if you only have one CPU or even two CPUs and you have 20 active processes that all want to execute, they will all be sitting there in the ready state, and the CPU scheduler will come along and decide from those in the ready state which one will get next onto the CPU. In other words, which one will be dispatched. The dispatch is the unit of the operating system that takes the next one that's ready, that the CPU scheduler has placed into the front of the ready queue and will actually be running. In the running state means that the process is actually using CPU cycles and executing its task. So after this process finishes the execution of its task, it would exit the system, and then it would be in a state of terminated. Now, most processes do not just come in, get ready, do a little CPU burst, and exit. Most processes come into the system, get ready, get their time on the CPU, and then they usually or possibly might be interrupted for some reason. Now, why would they be interrupted? Well, they might be interrupted because you're using a round-robin CPU scheduling algorithm and only allowing each process to have a certain amount of time on the CPU, or a process may be interrupted because a higher priority task comes along and interrupts this process. In which case, if a process does get interrupted, it will go right back into the ready queue and get queued up again and get to the front of the queue and be dispatched again onto the CPU. Another thing that can happen when a process is on the CPU, it may need to wait for an event. What that means is that some of the devices run slower than the process, or a process may be waiting for the result from another process, or for some reason, a process cannot continue its current CPU execution, so it needs to wait for the event, in which case it will then go into a blocked state. When the process is in a blocked state, there are different levels of blocked, and you will notice in your case study that this is a generalized blocked. It could be blocked waiting for a device, it could be blocked waiting for another process, it could be blocked for a number of reasons, but it's blocked because it's waiting for an event and it's not ready to execute because the event needs to occur in order for it to continue. As soon as the event has completed, the process will then be put back into the ready queue, get queued up by the CPU scheduler, and get to the front of the ready queue and then be once again dispatched onto the CPU and be in the running state. So processes migrate between, each process will migrate between the ready, running, and blocked or IO states. So you can consider the ready state as waiting for the CPU, the running state as running or executing, and the block state as blocked or IO or event state, meaning that it's blocked or it's in a state waiting for something to happen. But I would rather use the term waiting to indicate those that are waiting for the CPU, as you will see shortly in the CPU scheduler exercises. So that concludes our definition of what a process is. A process is an active entity. It comes from a program. Once the program becomes active and becomes a process, the operating system will create a process control block, or a PCB, for each active process in the system. And we also discuss the process states. So in the next video for this unit, we will talk more about processes. Thank you.